Assalamu alaikum everyone. Welcome to episode 3 of Study with Me O level chemistry. Currently we are doing past papers और ये आज जो है हम मई जून 2019 paper 1 solve करेंगे. This will be the part 1, which means we will be solving from question 1 to question 20. Okay, so let's begin. Bismillah. Question number 1. An experiment is done to measure the rate of reaction between calcium carbonate and dilute hydrochloric acid. The gas formed is collected in a gas syringe. Which additional pieces of apparatus are essential to know how the rate of the reaction changes with temperature and the amount of acid used? सबसे पहले तो it should be very clear to you what do we mean by rate. ठीक है. Now what is rate? Rate is actually any quantity, any physical quantity perhaps, divided by time. The truth about rate is that anything divided by time is actually rate. Even if you even if you put a constant up there 1 and you put the time down there, then the rate can even be defined as 1 over T being the time. So rate of reaction is in fact any quantity divided by time, and that quantity is a physical quantity when we talk about rate of reaction, because we are measuring the certain quantity, the change in a certain quantity with time, with respect to time. This can be let's say mass of the reactant as it decreases. It can be the volume of the, let's say, the product. If it's a gas being formed, it can be the temperature change, even it can be pH. Even there's no limit to these quantities. As long as it is changing with time, you can use it to find the rate. So I had to just clarify कि rate of reaction का असल में मतलब क्या होता है. ठीक है. अच्छा, हमने अब apparatus को देखना है, कौन सा हम temperature के लिए यूज करेंगे, कौन सा amount of acid used. Apparatus to measure temperature. And that's quite easy, right? We used thermometer to measure temperature. Everyone knows that. Apparatus to measure the amount of acid used. Now the amount of acid used, I mean, how will you vary the amount of acid? You can vary it by changing the volume of acid used, right? So how do you measure the volume? By measuring cylinder, not through a condenser. Condenser is what you see in simple distillation or fractional distillation, which actually converts the vapor of a liquid into liquid. Okay, so यहाँ पे condenser का कोई काम नहीं है. So the answer is D. Moving on. Question 2. I've already solved this question. I won't be repeating it. इसका आंसर जो है question 2 का D है. I won't repeat it. If you want to check it out, all of these questions that I will skip because there's a repetition. You need to go to May June 2019 paper 1 2 part 1 from question 1 to question 20. And if that question belongs to, if that question belongs from question 20 to question 40, then there's another video, May June 2019 paper 1 2 part 2. So I won't repeat the answers for these questions. ये repeated है, ये आपको part 1 में मिल जाएगा. Moving on. Question 3. A paper chromatography experiment is carried out to separate and identify the mixture of amino acids produced from the hydrolysis of a protein. Now, I hope you have seen my previous videos. If you have, then you would know that I also mentioned when we were doing question number 3 of May June 2019 paper 1 2, I said there were colorless acids and we were using a locating agent for them. And I specifically mentioned that there's a very concrete example in the syllabus that amino acids by nature are colorless, and for them we use a very famous locating agent known as ninhydrin. तो यहाँ पे देख लें उन्होंने amino acids की बात कर दी है. अब it's your luck that the examiner has mentioned locating agent in all 4 options. But if he had not, then अगर आपको ये ना पता होता कि amino acids colorless होती हैं, तो आप locating agent वाली option को select शायद ना करते. So इसलिए remember that. अच्छा, before I look at the options, let me clarify what do we mean by hydrolysis. Hydrolysis is actually, I'll just speak it out verbally, not write it down. Hydrolysis is a chemical reaction that breaks a larger molecule into smaller ones through the use of water. तो इसमें याद रखना है, ये जो हाइड्रो आपको आ रहा है ना, आप पढ़ते हैं ज्योग्राफी में भी आपने पढ़ा होगा, हाइड्रो इज काइंड ऑफ अ टर्म दैट इज यूज्ड फॉर वाटर. तो याद रखना. और लाइसिस का मतलब होता है ब्रेक डाउन. Let me mention that. Lysis means breakdown. And hydro we used to refer to water. So अगर आपको ये पता तो you can very easily know कि hydrolysis means the breakdown of a molecule using water. So remember, in hydrolysis we use water. It is in condensation that water is produced. In this we use it. ठीक है जी. तो which apparatus is needed? इसमें फ़र्क क्या लग रहा है आपको? COD में मुझे thermometer नज़र आ रहा है. We don't need a thermometer for chromatography because thermometer, as I said, is used to measure temperature. And why would we want to measure why would we want to measure temperature here, right? A and B को देखते हैं. Chromatography paper, locating agent, marker pen, pencil, ruler then नहीं है, solvent. Ruler चाहिए होता है because जब आपके पास क्रोमाटोग्राफी पेपर होता है तो आप रूलर से मेजर करते हो एक सर्टेन हाइट, लेट्स से 2.5 सेंटीमीटर. एफएससी की किताबों में ये 2.5 सेंटीमीटर का डिस्टेंस होता है, लिखा हुआ है बेसिकली. और यहाँ पे आप पेंसिल लाइन लगाते हो, रूलर से लगाते हो आप पेंसिल लाइन. ठीक है, इस तरीके से भी यू कुड हैव फिगर्ड आउट दैट बी इज द राइट आंसर. बट देयर इज ऑल्सो अनदर रीजन वाई बी इज द राइट आंसर, एंड दैट इज इधर पेंसिल लिखा हुआ है, इधर मार्कर पेन लिखा हुआ है. रिमेंबर वी ऑलवेज यूज अ पेंसिल टू ड्रॉ दिस लाइन. ठीक है, कभी भी मार्कर पेन यूज नहीं होता. व्हाई? बिकॉज अ मार्कर हैज इंक टू इट, राइट? उसकी जो मार्कर के अंदर असल में इंक होती है थ्रू विच we draw out things, and that ink itself is a mixture. So if you use a marker ink to draw this line, so if that marker ink is let's say soluble in that solvent that you are using, तो वो marker ink भी जो है ना वो ऊपर की तरफ कह लें कि उसकी भी आगे स्पॉट्स बनना शुरू हो जाएंगे. ठीक है, इस वजह से it can't be A, the answer will be B. Okay, moving on. Question number 4. Which conditions give the highest rate of diffusion? As I said in my previous videos, diffusion in your syllabus is only affected by two things. It is directly proportional to temperature, which means if you increase the temperature, you increase the rate of diffusion. And the second thing is diffusion is inversely proportional to the MR. So greater the MR, the lower or the slower will be the rate of diffusion. So if we want a good high rate of diffusion, then we require a high temperature because they're directly proportional. So this cancels out B and D. And then to have a high rate of diffusion, my MR should be low because only then diffusion rate will be high because they're inversely proportional. So molecular mass required is small. So the answer to this is C. Okay, let's move on. Question number 5. Cobalt is a transition element. A particle of cobalt contains 24 electrons and a nucleon number of 60. Which statement about this particle is correct? So let's write the nuclide, वो जो representation होती है, nuclide representation. Cobalt has a nucleon number of 60, and what will be the proton number? 24. Wrong. I intentionally wrote this down because this is what most of the students will do. They will think, oh, well, an atom is electrically neutral, so if there are 24 electrons, there will be 24 protons. Well, guess what? Is that always essential? And did the examiner mention it's an atom? No. He mentioned it's a particle. It's a particle. And that's a generalized term. Particle can refer to a molecule. It can refer to an atom. It can refer to an ion. So particle is a generalized term. They never said it's an atom. So I've even emphasized on this in my previous videos a lot. Cobalt has a nuclear number of 60. Nuclear number can alter. That the examiner has given himself. But the proton number for an element never, ever, ever changes. Because if that changes, then you are no longer talking about the same element. So if you look at the periodic table, the proton number for cobalt is 27. So remember, that is never changing. ठीक है? अब जरा लिख लेते हैं. My way of writing is always writing down neutron, protons and electrons separately. The neutrons will be what? 60 minus 27, that's 33. How many protons? 27. How many electrons given in the question? 24. Now you tell me, you have positive 27 here because you have 27 protons and protons are positive, and you have 24 electrons which are negative, so you're minus 24. What's the overall charge? Plus 3. So this means this is an ion. It's a cation perhaps, which has a charge of 3 plus on it. ठीक है ना? So remember, the proton number can never change. The number of neutrons, yes, they can change. That's how we get isotopes. Can the number of electrons change? Yes, they can change. That's how we get ions. Or particle, याद रखें, it's a generalized term. Okay, it can refer to either of these molecules, either of the particles that I've mentioned below. So let's look at the options. It is a 3 plus ion. Yes. It is a 3 negative ion. No. It contains 24 neutrons. No. It contains 24 electrons. It contains 24 protons. देखा ये गलती करते हैं बच्चे. नहीं. It has 27 protons. 24 protons होंगे तो हम एक different element की बात कर रहे होंगे. We would no longer be talking about the same element. ठीक है? अच्छा जी. So let's move on. Question number 6. Diamond and graphite are two different forms of the element carbon. We call these allotropes. Allotropes are the different forms of the same element. They each have different uses. Which row is correct? This is a knowledge-based question. Diamond, well, it is used to cut glass. I've even said it in my previous video that diamond is such a hard substance that we use it for cutting purposes. So because diamond is very, very hard, it is the hardest substance we know, it can cut glass very precisely and accurately because of its hardness factor. So it's a diamond. As an electrode, well, it's as an electrode, it's graphite, और वो तो फिर आगे खुद ही in sequence आ जाता है. So the answer is B. I'll give you the reasons. I gave you the reason for diamond. I said it can cut glass because it's one of the hardest substances we know. And therefore, the more hard something is, the more precisely and accurately it can cut, for example, something like glass. Why is graphite used as an electrode? आप मुझे बताइए electrode का काम क्या होता है? जब आप electrolysis पढ़ते हैं, you have this battery and you connect with it these electrodes and then you put it in this some kind of an electrolyte, right? What do we do through electrolysis? We use electricity to cause, remember this, electrolysis is used to cause some sort of reaction that does not happen on its own. यानी कि अगर मैं एक reaction को naturally करवाना चाहूँ तो वो naturally नहीं होता. Using electrolysis, using electricity, we force that reaction to happen. ये एक fact है. You can write this down. I know most of the teachers don't even mention it, but this is a fact. Electrolysis is used to cause such reactions that do not happen on their own. We use electricity to force them to happen. तो इसमें क्या होता है? इसमें electricity के through we use electricity to cause some kind of a chemical change in the electrolyte. ठीक है? अब आप मुझे बताएं ये electrode होता है. ये electrode क्या करता है? It basically conducts electricity to what? Into the electrolyte, right? यहाँ से electrons flow करते हैं, and so the electrolyte conducts the electricity coming from in here and it carries it towards the electrolyte. तो आप मुझे बताएं, does diamond conduct electricity? No. Does graphite conduct electricity? Yes. And as a lubricant, well, graphite is used as a lubricant. I mentioned this before also. There are hexagonal sheets in graphite of carbon, and they're arranged in layers, and they have these weak van der Waals forces in between. And because the forces between these layers are weak, they can actually easily slide if you push them. So I hope that makes sense. Let's move on. Answer is B. Question number 7. Well, the answer for that is C. I've done it before. I won't do it again. Question 8. What is the number of shared pairs of electrons in an ammonia molecule? Let's make ammonia. Nitrogen, hydrogen, hydrogen, hydrogen. Nitrogen has, let me use another color. Nitrogen has 5 electrons. So 1, 2, 3, 4. And what we do with the fifth one is we bond it here. So two electrons bond to form a pair in nitrogen, and the remaining 3 settle down here. With hydrogen, it only has one proton number because atoms are electrically neutral. If it has one proton, then it must also have one electron. So it uses its electron here and here, and that's how you get a ammonia molecule. It says how many shared pairs of electrons. This is a shared pair, this is a shared pair, this is a shared pair. 3 shared pairs. Answer for 8 is A. Again, I will repeat myself from the previous video. Shared pairs की बात हो रही है, so be very careful. अगर आपने shared को ignore कर दिया तो आप आंसर दे देंगे 4. अगर आपने shared को पढ़ा लेकिन आपने pairs को नहीं पढ़ा तो you would say 1, 2, 3, 4, 5, 6. So in either case your answer would be wrong. So do give your MCQs a good reading. Moving on. Well, the answer for this is D. I've done it before, won't repeat. Let's go on. Okay. 10. Again, repeated question from May June 2019 paper 1-2. Answer is D. Won't repeat. Moving on. In a volumetric experiment, 25 cm cube of it's actually called 25 cubic centimeter of 0.100 mole per dm cube sodium hydroxide reacts exactly with 20 cubic centimeter of sulfuric acid. What is the concentration of sulfuric acid? But a simple moles का question है. Remember, the first thing you want to do in a question for moles is to figure out the moles of one of the substances or one of the compounds that is involved. In here I've given the volume and I've been given the concentration of sodium hydroxide. Well, I can calculate the moles, can I not? We know moles of sodium hydroxide will be equal to what? Concentration into volume. What is the concentration? 0.1. What is the volume? 25 divided by 1000. Okay, and the answer to that turns out to be 2.5 into 10 raised to the power of -3 moles. Now that I have the moles of sodium hydroxide and I can basically calculate the moles of either of these compounds now, but what we are interested in is sulfuric acid. So let's find the moles of sulfuric acid. We know this is NaOH ratio H2SO4. NaOH is 2 ratio and H2SO4. This is 2 ratio 1. And the moles of NaOH is 2.5 into 10 to the power of -3. So X will basically be the half of that. That's 1.25 into 10 to the power of -3 moles. Acha ji. Now that I have moles of H2SO4 and I've already been given the volume of H2SO4, can I find the concentration? Well, hell yeah. Because concentration is moles, we actually use the letter N for moles. N divided by V, moles over volume. What is the moles? Moles are 1.25 into 10 to the power -3, and the volume is 20 divided by 1000. Acha, the answer will turn out to be 0.0625 moles per dm cube. I actually want to give a very short tip over here. For that, I would have to erase this. Wait a second. I'll write it down again, but I'll write it in another way. You know, कोई थोड़ी बहुत mental maths भी इंसान को आनी चाहिए. देखिए, concentration is moles over volume, right? The moles are 1.25 into 10 raised to the power of minus 3. Can I write the volume as 20, ठीक है, into 10 raised to the power of minus 3? Why am I saying that? देखिए आपने मैथ से पढ़ा होगा, if it's 1 over a raised to the power of 2, then if you bring it in the numerator it becomes a minus raised to the power of minus 2. तो जो नेगेटिव पावर रखती थी उसको हम डिनोमिनेटर में ले जाते थे तो उसकी पावर पॉजिटिव हो जाती थी, राइट? यू रिमेंबर दैट रूल? So tell me this thing, if I have 20 over 1000, right, can I write this as 20 over 10 raised to the power of 3? Because 10 raised to the power of 3 is what? 10 into 10 is 100, 10 and 100 into 10 is 1000. So can I write this down as that? I can, right? So can I take it at the top now and write it down as 10 into raised to the power of minus 3? ठीक है, तो एक बात याद रखना, dividing something by 1000 or multiply something by 10 raised to the power of minus 3 is the same thing. It is the same thing. ठीक है, I'm gonna rub this off now, ये वाली बात, ठीक है? इस वजह से I wrote this down as into 10 raised to the power of minus 3. और इसका इससे पता है easy किस तरीके से हो जाता है क्वेश्चन? You can simply cancel out 10 raised to the power of minus 3, 10 raised to the power minus 3, क्योंकि numerator and denominator में चीज़ें multiply हो रही हैं and it's the same thing up and down, so you can basically cancel it out. Now I have 1.25 divided by 20. You see how you can actually simplify a question if you just use a bit of mathematics. अब आप 1.25 divided by 20 फ़ौरन से अपने कैलकुलेटर में डालें और फ़ौरन से आंसर आ जाएगा 0.0625. ठीक है, but if you're not confident with these rules then I don't recommend that you use them, क्योंकि फिर एमी आप अपना जवाब गलत ना कर दो. अच्छा जी, ये सॉल्व हो गया. अब हम नेक्स्ट क्वेश्चन पे चलते हैं. क्वेश्चन नंबर 12. The reaction for the conversion of bromoethane to ethanol is shown. In an experiment, 10.090 grams of bromoethane is converted to 3.45 grams of ethanol. What is the percentage yield? What is the percentage yield? आप मुझे बताएं, what is the formula for percentage yield? It is the actual mass over the theoretical mass. This will be given to you in the question and it has been 3.45 grams of ethanol. They have already told us. वो क्योंकि परसेंटेज यील्ड ऑफ एथेनॉल मांग रहे हैं ना, तो एथेनॉल की उन्हें हमें एक्चुअल मास दे दिया हुआ है कि जब हमने 10.09 ग्राम्स ऑफ ब्रोमोइथेन यूज़ किया तो हमारे पास 3.45 ग्राम्स ऑफ एथेनॉल आ गया. ठीक है, सो दे हैव ऑलरेडी गिवन अस द एक्चुअल मास. थ्योरेटिकल मास इज व्हाट यू मेजर यूजिंग द मोल्स इन थ्योरी. जब आप मोल्स को इन थ्योरी यूज़ करते हो तो जो आपके पास मास थ्रू दोज कैलकुलेशंस आते हैं उसको हम थ्योरेटिकल मास कहते हैं. And remember, percentage yield is always less than 100%. हमेशा, because actual yield will always be less than theoretical yield. Because जब आप actually practically एक चीज़ को perform करते हो lab में, तो there are many, your experiment is prone to many errors. उन errors में you can basically decrease the mass in one way or another. इस वजह से. अच्छा, so percentage yield हमने ढूंढनी है. अब मुझे ब्रोमोइथेन का मास पता है, तो आई सेड पहली चीज़ हम क्या करते हैं, हम मोल्स ढूंढते हैं. तो लेट्स फाइंड मोल्स ऑफ ब्रोमोइथेन. दैट्स 10.090. एग्जामिनर हैज़ एक्चुअली मेड थिंग्स इजी फॉर यू. ने आपको वैसे ही ये जो है वो लिख कर दे दिया है. आंसर आता है 0.1 मोल. ठीक है, 0.1 मोल्स आ गया. अब मुझे बताएं मोल्स ऑफ C2H5OH कितने होंगे. यू कैन क्लियरली सी दीज आर इन 1:1. तो जो 1:1 है तो जो इसके मोल्स होंगे उतने इसके हो जाएंगे, तो ये भी 0.1 मोल्स होंगे. नाउ आई हैव द मोल्स. मोल्स इज मास ओवर MR. मोल्स आर 0.1. mass of C2H5OH I'm interested in, that's a theoretical mass, and the MR is 46. Answer आता है 4.6 grams. So I have the theoretical mass now. I have the actual mass now. All I have to do is put it in the equation. Either I forgot to mention multiplied by 100 to make it a percentage. Okay. So this will be 3.45 over 4.6 into 100. That turns out to be 75%. ठीक है जी, तो आपका आंसर बनता है C. Let's go on. 1 mole of sugar is burned. What volume of oxygen measured at room temperature and pressure? Room temperature and pressure की बात हो रही है. We're talking about RTP is required for complete combustion of the sugar. सबसे पहले let me expand this. This will be C6H12O6. Does it sound familiar? This is glucose. ठीक है, ये ग्लूकोज की बात कर रहे हैं. अच्छा, let's form the combustion equation for glucose. C6H12O6 oxygen giving me CO2 plus, actually I should leave some space, CO2 plus H2O. 6 carbons, 12 hydrogen, and then I have 12 plus 6, 18 oxygen on this side, 6 oxygen are already in here, remaining 12, so 6 here because that makes it 12. Achha, does this equation sound familiar? I hope it does. I just sincerely hope it does. Because if it doesn't, then I'm concerned. I mean, if you take O-level biology, then you must know that this is the equation for respiration. ये तो हिंस हो जानी चाहिए, ठीक है. This is the equation for respiration. और यहाँ पर what did the examiner say? Because we are speaking in the language of chemistry, we say write the complete combustion equation of the sugar, which was glucose. So this is also the complete combustion of glucose. Maybe, just maybe, at this point you are thinking, does that mean that respiration and combustion are the same thing? Well, the answer is respiration and combustion are similar. I didn't say same, I said similar to one another. Yes, they are similar to one another, but they're not the same thing. Because respiration O levels mein all you are told is this simple equation, but when you go into A levels you will see that the reaction is much more complicated than just this. ये तो एक overall equation आपके लिए लिख दी गई है respiration की. असल में इसमें बहुत सारे steps होते हैं, inter conversions होती हैं, फिर जाके ये 6 carbon dioxide and 6 water molecules बनते हैं. तो respiration is not just this equation. It's much more complicated than this equation. This is, you can say, this is the net equation for respiration. But they are similar, let me tell you that. Respiration and combustion are similar, and respiration can be technically called combustion, but they are not same. ठीक है जी, पहले ही बात clear हो जाए, ठीक है. This is like something worthwhile knowing. अब हम आते हैं क्वेश्चन पे. ये देखिए, उसने कहा कि what volume of oxygen is required, at RTP. अब बंदा इस क्वेश्चन में सोचे कि यार मोल्स का क्वेश्चन लग रहा है, but they haven't given us moles for anything, neither the mass of anything, neither the volume of anything, neither the concentration of anything. So where do I begin from? How do I even solve this question? Well, note how the examiner said which volume of oxygen measured at RTP is required. I hope you know ये चीज़ एवोकाडोस के लॉ के साथ हम derive करते हैं और ये काफ़ी famous है, और I'm hoping that your teacher has also told you, and that is that 1 mole of any gas at RTP has a volume of 24 dm cube. You can even call this as 24 liters. You can even call this as 24,000 cm cube. I hope your teacher told you that. और ये जो वॉल्यूम होती है ना, ये जो वॉल्यूम होती है 24 dm cube वाली, यानी कि जो 1 mole of any gas at RTP occupy जो करती है वॉल्यूम, which is 24 dm cube, we call this as the molar volume of a gas. What? Molar volume of a gas. ठीक है, इफ यू डिडंट नो दिस नाउ यू नो इट, सो मेमोराइज इट। ठीक है, और सिमिलरली अगर एग्जामिनर आरटीपी की बात ना कर रहा होता, एसटीपी की बात कर रहा होता, विच इज़ स्टैंडर्ड टेम्परेचर एंड प्रेशर, तो हम कहते हैं कि 1 मोल of any gas at STP has a volume of 22.4 dm cube. You can even call this as 22.4 liters, even call this as 22400 cm cube. ठीक है, तो pause this video right now and write this down if you didn't know this before. But इससे पहले एक और चीज़ मैं बता दूँ, ये conversions आपको आनी चाहिए। 1 dm cube is equal to 1 liter which is equal to 1000 cm cube या cubic centimeter which is equal to 1000 milliliters। ये conversions आनी चाहिए for mole, so memorize them। ठीक है, and actually 1 cubic meter is equal to 1000 cubic dm cube, cubic dm cubic, well funny, खैर ये conversions आपको आनी चाहिए। ठीक है, इस चीज़ को नोट डाउन कर लें वेरी क्विकली। पॉज द वीडियो एंड नोट इट डाउन। ओके, डन, टाइम टू रब दिस ऑफ। अब जल्दी से रब ऑफ करते हैं क्योंकि हमने क्वेश्चन भी सॉल्व करने हैं, हम बैकग्राउंड पे ही बात कर रहे हैं। बट यू नो आई रियली वांट टू मेक द बैकग्राउंड क्लियर फॉर स्टूडेंट्स बिफोर आई हॉप ऑन टू डूइंग द क्वेश्चन, क्योंकि वही तो असल बात है। वी नॉट इंटरेस्टेड इन द राइट आंसर, वी इंटरेस्टेड इन द राइट मेथड ऑफ सॉल्विंग अ क्वेश्चन। अच्छा, इसके साथ मैं एक और चीज़ डिक्टेट कर दूँ, एस टी पी। हाँ, वैसे ये बतानी भी ज़रूरी है, एस टी पी इज़ स्टैंडर्ड टेम्परेचर एंड प्रेशर। इसके अंदर द टेम्परेचर इज़ considered to be 0 degree Celsius or 273 K, which is Kelvin, and the pressure is considered to be 1 atm slash 101.3 kilopascals, even as 101.325 to be very exact, and even as 760 millimeters of Hg, which is mercury। ठीक है, ये नोट डाउन कर लें क्विकली। पॉज द वीडियो, नोट दिस डाउन। ओके, Similarly, RTP stands for normal room temperature and pressure. So, room temperature plus pressure and pressure होता है वैसे, and the temperature here is considered to be 25 degrees Celsius, 298 Kelvin, and the pressure is the same, which is 1 atm or 101.3 kilopascals, or to be very exact 101.325 pascals or 760 millimeters of mercury। यहाँ पे आप नोट कर रहे हैं कि अगर आपने डिग्री सेल्सियस से जाना हो टू केल्विन तो आपने बेसिकली प्लस 273 करना होता है। नोट दैट डाउन एज वेल। अच्छा जी, काफ़ी देर हो गई इस क्वेश्चन पे। पॉज द वीडियो, नोट इट डाउन, देन वी आर मूविंग ऑन। ओके, लेट्स मूव ऑन वेरी क्विकली। ओके, सो अब आई सेड, बात हमने की थी कि 1 मोल ऑफ एनी गैस एट RTP occupies 24 dm cube of volume। तो इसका मतलब है कि जब एक चीज़ 1 मोल एट RTP ऑफ एनी गैस ऑक्यूपाई कर रही है 24 dm cube को, राइट, एंड वी आर इंटरेस्टेड इन द वॉल्यूम ऑफ ऑक्सीजन, तो ऑक्सीजन जो है वो कितनी है यहाँ पे, 6, देयर आर 6 मोल्स, राइट, 6 मोल्स। How many will they occupy? Cross multiply. So that's 6 into 24, and that will be 144 dm cube. So the answer is C. Okay, let's move on. Question number 4. Which statement about purification of copper by electrolysis is correct? यार ये जो टॉपिक है ना, प्योरिफिकेशन ऑफ कॉपर, ये बहुत सारे स्टूडेंट्स को क्लियर नहीं होता, एंड ये इतना आसान टॉपिक है, मेरे दिल में दर्द होती है। तो उसको हल्का करने के लिए हम इसको पढ़ेंगे। आई रियली वॉन्ट टू टीच दिस टॉपिक बिकॉज इवन व्हेन आई वाज इन ओ लेवल्स मुझे भी कहीं ना कहीं इस टॉपिक पे बड़ी कन्फ्यूजन होती थी। तो So let's just cover this up for once and for all. Purification of copper. यही था ना? Yeah. So how is this done? Well, what we do is, this is not just for copper. For the purification of basically any metal, you can carry electrolysis out. तो किसी भी मेटल अगर वो इम्प्योर है, आपने उसको प्योर करना है, उसकी इम्प्योरिटीज को रिमूव करना है, आप कौन सा मेथड ऑक्यूपाई करेंगे? ऑक्यूपाई नहीं, मतलब चूज करेंगे, दैट्स इलेक्ट्रोलिसिस. रिमेंबर दैट, electrolysis. Okay, let's first make up the setup. What does electrolysis look like for this? So you have a battery, because in electrolysis we use electrical energy to cause some sort of a chemical reaction. Remember that in electrolysis, the anode will always be the positive one, and the cathode will always be the negative electrode. ये बात बिठा लें. But I said for electrolysis. ठीक है, just for electrolysis. And then you have this container, उसके अंदर electrolyte होती है. Now, because this is the positive terminal, remember that the longer line represents the positive terminal of a cell and the smaller side represents the negative side of the cell. तो ये positive हो गया, negative हो गया. So technically this is the anode and this is the cathode. Now, for purification of any metal, remember that the impure metal, let's say this is the impure metal, right? The impure metal, in this case, the impure copper is always the anode. So the anode is always impure copper. Remember that, always impure copper. And the cathode is always what? Pure copper. ये बात जिस मेटल को भी, जिसको भी आप प्योरीफाई करें, इम्प्योर फॉर्म उसकी एनोड पे आएगी और प्योर फॉर्म आपकी किस पे आएगी? उसके कैथोड पे आएगी. ठीक हो गया. एंड व्हाट डू वी यूज एज द इलेक्ट्रोलाइट? Well, the electrolyte used is, listen very carefully, it is an aqueous solution of the soluble salt of that metal. तो आपको कोई aqueous solution चाहिए, बट ऐसी चीज़ की, ऐसे उसकी salt चाहिए जो soluble हो aqueous solution में. यानी कि aqueous कैसे होगी? अगर वो पानी में soluble हो. तो copper sulfate जो है वो एक बहुत famous example है. ये blue in color होती है. ठीक है, कॉपर सल्फेट हम यूज़ करते हैं बिकॉज दिस इज सॉल्युबल इन वाटर एंड देयरफॉर इसको हम एक्वस लिखते होते हैं. सो द इलेक्ट्रोलाइट इज ऑलवेज द सॉल्युबल सॉल्ट ऑफ दैट मेटल, विच इनसॉल्युबल का मतलब है कि वो पानी में डिजोल्व कर जाएगी, तो एक एक्वस सोल्यूशन होगी. ठीक हो गया. अच्छा, अब क्या होता है? अब व्हाट हैपेंस इज दैट यू पास इलेक्ट्रिसिटी. सो यू पास इलेक्ट्रिसिटी थ्रू द सर्किट. सो इलेक्ट्रोड उसको कंडक्ट करते हैं टुवर्ड्स द इलेक्ट्रोलाइट. व्हाट हैपेंस? The anode starts dissolving in the electrolyte. ठीक है, एनोड पे ये होना शुरू हो जाता है. एनोड पे जो कॉपर एटम्स होते हैं, ठीक है, वो क्या करते हैं कि वो कॉपर 2+ आयंस बना के अपने 2 इलेक्ट्रॉन्स इसी एनोड के ऊपर छोड़ जाते हैं. ठीक है, सो दे लीव बिहाइंड देयर 2 इलेक्ट्रॉन्स एंड दे फॉर्म कॉपर एटम्स, फॉर्म कॉपर 2+ आयंस एंड दे गो इनटू द सॉल्यूशन. तो वो इधर से सॉल्यूशन में चले जाते हैं. एंड व्हाट इज दिस? देयर इज अ लॉस ऑफ इलेक्ट्रॉन्स. व्हाट इज लॉस ऑफ इलेक्ट्रॉन्स? ऑक्सीडेशन. ठीक है, वी से द एनोड स्टार्ट्स डिसॉल्विंग. किसी भी मेटल को अगर आप एनोड पे लगाएं और अगर आप उसकी इलेक्ट्रोलाइट में उसकी कोई सॉल्युबल सॉल्ट रख दें, तो वो हमेशा उसकी एनोड डिसॉल्व कर जाएगी. रिमेंबर दैट, दिस इज फॉर ऑल मेटल्स. आप उसको एनोड पे लगाओ, ठीक है, और आप उसकी एक सॉल्युबल सॉल्ट दे दो उसको, वो हमेशा डिसॉल्व आउट कर जाएगा. दिस इज नॉट ओनली फॉर कॉपर बट फॉर ऑल मेटल्स. ठीक है. व्हाट हैपेंस एट द कैथोड एट द सेम टाइम? अब जैसे जैसे एनोड स्टार्ट्स इंक्रीजिंग द कॉन्सेंट्रेशन. अच्छा, कॉन्सेंट्रेशन के लिए हम केमिस्ट्री में ये ब्रैकेट्स यूज करते होते हैं. ठीक है, सो एज द कॉन्सेंट्रेशन ऑफ कॉपर 2+ स्टार्ट्स इंक्रीजिंग, व्हाट हैपेंस? क्या वो बढ़ती चली जाती है? नहीं. At the cathode, at the same time, simultaneously, copper 2+ ions gain 2 electrons because the cathode is negatively charged. Can you see? तो उस पर excess of electrons है. तो copper 2+ ions जो solution में होते हैं वो उसको approach करते हैं cathode को, 2 electrons gain करते हैं and they give copper atoms. And what is this? This is a gain of electrons. What is that? That's reduction. ठीक हो गया. So this is what's happening at the anode, this is what's happening at the cathode. अब ये कैथोड पे क्या हो रहा है, कॉपर 2 प्लस आयंस की कॉन्सेंट्रेशन डिक्रीज कर जानी चाहिए बिकॉज ऑफ व्हाट इज हैपनिंग एट द कैथोड. But because these two reactions are happening simultaneously, that the anode keeps on increasing the concentration of copper 2 plus ions and the cathode keeps on decreasing the concentration of copper 2 plus ions. और वो क्योंकि 1-1 मतलब same ratios में हो रहा होता है, तो overall we say that the color, the blue color perhaps, the blue color of the electrolyte remains the same. It remains the same. It does not fade. ठीक है, जब हमने ग्रेफाइट के इलेक्ट्रोड यूज किए थे तो हमारे पास कैथोड पे कॉपर आया था और हमारे पास एनोड पे जो है वो ऑक्सीजन गैस आई थी. उस टाइम पर क्या हुआ था कि ब्लू सोल्यूशन उसकी फेड होती गई थी. क्यों? क्योंकि जो कॉपर 2 प्लस आयंस की कॉन्सेंट्रेशन थी वो सोल्यूशन में डिक्रीज कर रही थी. बट इस टाइम पे इट्स नॉट डिक्रीजिंग because it's increasing and decreasing at the same rate. We say the blue color of the electrolyte remains the same. It does not fade. ठीक हो गया. इसके अलावा और क्या ऑब्जर्वेशंस होंगी? ऑब्जर्वेशन ये होगी कि जो आपका कैथोड है इट विल इंक्रीज इन साइज. यू कैन इवन से द मास ऑफ द कैथोड विल इंक्रीज, द एनोड विल डिसॉल्व, सो द एनोड विल डिक्रीज इन साइज, एंड यू कैन से द मास ऑफ द एनोड विल डिक्रीज. और एट द सेम टाइम हम ये भी कह सकते हैं दैट द पिंक solid is deposited on the cathode. हम ये भी कह सकते हैं कि the color of the electrolyte will remain the same. So these are some of the observations. और कलर क्यों सेम रह रहा है? क्योंकि कॉपर 2 प्लस आयंस की कॉन्सेंट्रेशन कांस्टेंट रह रही है. ठीक है. उसके अलावा एक और बात, जब आपका एनोड डिसॉल्व करता है ना इन, और वो हमेशा डिसॉल्व करेगा इन दी सॉल्युबल इन दी एक्वा सॉल्यूशन ऑफ इट्स सॉल्युबल सॉल्ट ऑफ दैट मेटल, तो उधर जो इम्प्योरिटीज होती हैं वो नीचे गिर जाती हैं बिकॉज वो सॉल्युबल नहीं होती in that electrolyte. They're not soluble in that aqueous solution. तो क्योंकि जो impurities होती हैं on copper, they are not soluble in the electrolyte, they fall down at the bottom of the container and we call this as the anode sludge. क्या कहते हैं इसको? हम anode sludge कहते हैं. ठीक है. So I hope कि अब आपको ये वाला जो टॉपिक है वो क्लियर होगा. ठीक है. और याद रखना, if you do the electrolysis of copper sulfate aqueous using graphite electrodes which are inert, you will get copper at the cathode and oxygen at the anode. But if you change if you change the electrodes to that of copper, तो anode हमेशा dissolve कर जाता है in the aqueous solution of the soluble salt of the metal जिससे वो खुद बना हुआ. ठीक है. So electrolysis can be used to purify metals. So और आप से एक और conclusion draw कर सकते हो कि if you change the nature of the electrodes or the material of the electrodes, you can change the products. ठीक है. अब बहुत बातें हो गई हैं, जल्दी से हम इस पे जाते हैं. Which statement about purification of copper by electrolysis is correct? A pure copper anode is used. Is it? No, I said at the anode we always use the impure copper. तो इस वजह से A is wrong. A pure copper cathode is used. Yes, I told you that the cathode is always the pure copper. जो हम electrode 1 use करते हैं, तो B is the answer. The color of the electrolyte fades. No, it does not. It will fade if the electrodes would have been graphite. ठीक है, क्योंकि उसमें कॉपर आपका डिस्चार्ज होता रहता है तो उसकी कॉन्सेंट्रेशन गिरती है. इधर क्या हो रहा है? इधर वो बढ़ भी रहा है, कम भी हो रहा है, तो उसकी ओवरऑल कॉन्सेंट्रेशन कांस्टेंट रिमेन करती है. D, the electrolyte used in a solution is a solution of copper oxide. नहीं हो सकता. Why? Copper oxide is not soluble in water. ठीक है. And I said you need an aqueous solution of a soluble salt of that metal. Oxide सिर्फ metal group 1 की soluble होती हैं और group 2 की थोड़ी बहुत soluble होती हैं. ठीक है. तो ये copper oxide यहाँ पे उसमें नहीं आता. This I know because of the solubility table. ठीक है. तो आंसर वो बी हो जाता है. बहुत हमने इस पे बात कर लिया, अब जल्दी से आगे हमने इसको ख़त्म करना है. Which negative ions are present in aqueous copper 2 sulfate? मुझे बताएं कौन से होंगे? There is aqueous solution, so there are also hydroxide ions present, and then sulfate ions from copper 2 sulfate. So answer is C. 16. The diagram shows the energy profile for a reaction. Which statement about this reaction is correct? मैंने कहा था कि अगर आप डायग्राम को याद कर लें in the previous videos, so it's good. But अगर आप कभी भूल भी जाएं तो याद रखिएगा कि जो डेल्टा एच का एरो होता है इट ऑलवेज गोज फ्रॉम द रिएक्टेंट्स टू द प्रोडक्ट्स, और अगर एरो ऊपर हो तो उसका क्या मतलब है, डेल्टा एच इज पॉजिटिव, और अगर वो नीचे होता तो उसका मतलब होता कि वो रिएक्शन एक्सोथर्मिक है. So if the arrow points upwards, it's positive, it's endothermic. If it points downwards, it's exothermic. वो नेगेटिव हो जाएगा. तो एक्सोथर्मिक नहीं है फॉरवर्ड रिएक्शन, क्योंकि हम रिएक्शन फॉरवर्ड की बात कर रहे थे जनरली. यहाँ पे इवन तो उसमें फॉरवर्ड नहीं कहा, बट इट्स काइंड ऑफ वेरी ऑब्वियस है कि हम इस तरह देखते हैं यूजुअली, अनलेस अदरवाइज स्टेटेड. ठीक है, तो हमेशा रिएक्टेंट्स टू प्रोडक्ट्स एरो जाएगा, दैट मेक्स इट एंडोथर्मिक. एंड जो एक्टिवेशन एनर्जी है वो मैंने कहा था उसको हम हमेशा रिएक्टेंट्स टू द पीक मेजर करते होते हैं ऐसे. ठीक है, दिस इज द एक्टिवेशन एनर्जी. अच्छा, लेट मी गिव अ वेरी क्विक टिप. रिमेंबर द डेल्टा एच एरो will always go from reactants to products. Okay, but the value of delta H will always be calculated by finding the energy of the products and subtracting it from that of the reactants. ठीक है, ये बहुत इंपॉर्टेंट बात है मैं यहाँ कर रही हूँ. एंड द एक्टिवेशन एनर्जी, ये क्या हो गया, एक सेकेंड भाई. The activation energy, okay, always goes from reactants to peak of the graph, and the value of activation energy is always found by the energy at the peak of the graph minus the reactants. ये बात याद रख लें, ज़िंदगी बहुत आसान है इसके बाद इस टॉपिक में. तो आप मुझे बताएं, the reaction is endothermic. What will be the activation energy? It's peak minus the reactants की energy. So peak कहाँ पर आ रही है, P, right? Peak पे कितनी energy है, P, और reactants के पास कितनी energy, R. So it's P minus R. So that's B. आंसर B हो गया. Let's move on. Okay, ये क्वेश्चन मैंने सॉल्व पहले कर दिया हुआ था, ये आपको मिल जाएगा May June 2019 पेपर 1 to part 1 में. So the answer is A. Moving on. 18. 3 experiments are carried out in which the same mass of magnesium है, ठीक है, वो रिएक्ट कर रहे हैं विद द सेम वॉल्यूम ऑफ डाइल्यूट सल्फ्यूरिक एसिड एट रूम टेम्परेचर. द मैग्नीशियम इज इन एक्सेस. एक्सपेरिमेंट्स दी हुई है, कहते हैं भाई विच रो इज करेक्ट. अच्छा, लार्ज पीसेस ऑफ मैग्नीशियम आर यूज्ड. इससे क्या होगा, रेट डिक्रीज कर जाएगा, है ना, क्योंकि जब आप व्हेन यू यूज लार्ज पीसेस यू हैव लेस सरफेस एरिया टू रेशो टू वॉल्यूम रेशो. तो उस वजह से क्या होती है कि आपका जो रेट ऑफ द नंबर ऑफ सक्सेसफुल कोलिजन्स पर यूनिट टाइम होती हैं वो डिक्रीज कर जाती है. सो द रेट डिक्रीजेस. स्मॉलर पीसेस ऑफ मैग्नीशियम आर यूज्ड. दिस विल इंक्रीज द सरफेस एरिया पर यूनिट, पर यूनिट वॉल्यूम. एंड जब रेट उससे क्या हो जाएगा, बढ़ जाएगा, क्योंकि मोर सक्सेसफुल कोलिजन्स पर यूनिट टाइम. एक्सपेरिमेंट 3, लार्ज पीसेस, तो इसमें रेट क्या होगा, स्लो होगा, बट कॉन्सेंट्रेशन ऑफ द एसिड इज यूज्ड. अब मुझे बताओ, मैंने आपको एक पहले भी लास्ट वीडियो में बताया था that the volume of you can say the amount of product can only increase if, इसको मैं डिफरेंट कलर से लिख देती हूँ, if you increase the number of moles of the reactants या reactant. अब मुझे बताओ, यहाँ पे we have magnesium reacting with H2SO4, right? They said that the mass of magnesium is constant, so this is constant. ठीक है, ये जब constant है तो ये तो vary नहीं हो रहा. So or we know that moles, I said you can change the number of moles if you change the mass, volume, concentration. अगर ये 3 चेंज हों तो फिर देयर इज अ चांस कि मोल्स आपने बढ़ा दिए या फिर मोल्स में चेंज आया. बट यू ऑल्सो हैव टू वेरीफाई दैट. ठीक है, क्योंकि अगर कॉन्सेंट्रेशन बढ़ रही हो, वॉल्यूम कम हो रही हो, तो मोल्स नहीं बढ़ेंगे. ठीक है, तो आपने उसको वेरीफाई करना होता है. अब इधर आ जाते हैं H2SO4 पे, देखते हैं अगर H2SO4 के मोल्स बढ़ रहे हैं. मोल्स इज कॉन्सेंट्रेशन इनटू वॉल्यूम. ठीक है, नाउ दिस सेड द कॉन्सेंट्रेशन ऑफ द एसिड इज इंक्रीज. कॉन्सेंट्रेशन आपने बढ़ा दी है, ठीक है, but they said that the volume of dilute sulfuric acid is kept same. This is constant, volume is constant, but we increase the concentration. तो अगर कॉन्सेंट्रेशन बढ़ी है, वॉल्यूम कांस्टेंट रही है, तो फिर मोल्स को क्या होगा? मोल्स डिपेंड्स ऑन दीज टू फैक्टर्स. ये तो कांस्टेंट है, ये बढ़ गया, तो फिर मोल्स भी बढ़ जाएंगे. And if the moles of the reactant, one of the reactants increases, the volume of the product formed will also increase. तो इसके अंदर रेट तो स्लो होगा, बट हमारे पास प्रोडक्ट जो होगा वो ज़्यादा आएगा. Now let's look at the options. Which row is correct? Experiment 1. Experiment 1 थी large pieces of magnesium are used. पहले हम 3 को कर लेते हैं, ज़्यादा आसान. I said rate is slow, product is more. We only see the graph W showing that. तो experiment 3 तो W है, तो उससे A और C चले जाते हैं. और हमें पता है एक्सपेरिमेंट 2 में द रेट विल बी फास्टर देन एक्सपेरिमेंट 1. सो यहाँ पर द रेट इज इन x इज फास्टर देन y, सो एक्सपेरिमेंट 2 विल बी x. सो द आंसर विल बी D. ठीक है, लेट्स मूव ऑन. क्वेश्चन नंबर 19. The equations show 4 reversible reactions for which reaction would the equilibrium move to the right for both an increase in pressure and increase in temperature. यानी दोनों फेवर करेंगे फॉरवर्ड रिएक्शन को. अच्छा, increase in temperature favors endothermic reactions, not exothermic, तो that eliminates D and A. So it's either B or C. क्योंकि जो endothermic reaction होता है वो absorb करते हैं heat को, right? तो जब आप temperature को increase करते हो तो जो system होता है it tries to favor that reaction which will absorb that heat, so we can maintain the equilibrium. Increase in pressure. Increase in pressure favors the side with less gaseous moles. Let's see, gas 10 moles here, gas 9 moles here. So we can see that the forward reaction in this case, or the reaction going towards the right, has less gaseous moles on the product side. So if I increase the pressure, I will favor the forward reaction and the position of the equilibrium will shift towards the right. Over here I have 1 mole and 2 moles, तो वो तो backward reaction को favor करेगा if I increase the temperature. So the answer is B. Moving on, question number 20. Gas X turns acidified potassium manganate from purple to colorless, and gas Y turns aqueous potassium iodide from colorless to brown. अच्छा, बहुत ध्यान से सुनना ये. Acidified potassium manganate 7, I hope you know and you should know, is an oxidizing agent. Okay, and aqueous potassium iodide, I hope you know and you should know, is a reducing agent. What is an oxidizing agent? Oxidizing agent is something that causes oxidation. Causes oxidation. What happens to itself? What happens to the oxidizing agent itself? It gets reduced. So it reduces. So the oxidizing agent causes oxidation, but it is reduced itself. What happens to a reducing agent? A reducing agent causes oxidation, causes reduction, but itself is oxidized. याद रखिएगा, for a redox reaction, there's always an oxidizing agent plus a reducing agent reacting with each other. सिर्फ तभी काम बनता है, ठीक है? So if gas X made this oxidized agent go from purple to colorless, which happens when acidified potassium manganate oxidizes something. जब acidified potassium manganate किसी चीज को oxidize कर देता है, तब वो purple से colorless चला जाता है, क्योंकि वो खुद reduce हो जाता है. So listen to this carefully. If acidified potassium manganate is the oxidizing agent, then gas X will be what? The reducing agent. Refer to this. Gas X is the reducing agent. Because you know, it has reduced acidified potassium manganate. And acidified potassium manganate being the oxidizing agent has oxidized gas X. ठीक है? अच्छा, इधर this is the reducing agent, it has been oxidized itself. So then gas Y is the oxidizing agent. Because if this is the oxidizing agent and this is the reducing agent, सिर्फ तब एक redox reaction होगा. और तब भी एक aqueous potassium iodide will go from colorless to brown, which shows it's being oxidized. So gas Y is oxidizing agent. Gas X is reducing, gas Y is oxidizing. So the answer to this question is C. अच्छा जी, That's it for today, guys. I'm actually super tired after this lesson, but I hope this made sense. All of these questions, I hope it's clear. I will come very soon with another video completing this paper. इस तरीके से हम इसको पास पेपर सेशन प्रैक्टिस को जारी रखेंगे. I don't know how many papers I will do exactly or how many years I will cover, but I will try my best. If you guys want more information, then in the description box below, I've left the link for the Instagram account for OTA. You can visit us and you can basically check the ongoing sessions, because we do have a P1 past paper session which is coming, which is actually starting from the 4th of August at very minimum price. And other than that, you will still, maybe not very frequently, but you will keep getting these kind of videos as well. If you liked it, give it a thumbs up, leave a comment, subscribe if you haven't, and till then, Khuda Hafiz.